This is the Chapter 4, Section 2 podcast. The topic is speed, and the first concept we're going to talk about is talking about how you can calculate the speed of an object by dividing the distance covered by the time. Now, when Galileo was alive, people usually describe things very vaguely with either words like slow or fast. And Galileo is credited as the first one to actually measure speed, considering how far something travels and the time it takes to travel that distance. So speed, we're going to define it as how fast an object is moving. Mathematically, we're going to represent it as speed equals distance divided by time. As you can see, there's going to be a little math in this section. Units for speed can be anything, any pair of units that are units for distance and the unit for time. Here are some examples: miles per hour, like in an automobile; kilometers per hour, which is what a lot of other people measure speed in an automobile; centimeters per day, maybe think of like a snail traveling; and light years per century, maybe that's light leaving our world and traveling somewhere else, or light from the sun traveling somewhere. Here's a cheetah. Cheetah is the fastest land animal at short distances, under 500 meters. They can reach speeds of 100 kilometers per hour. So sorry about that, kilometers per hour. Unit of distance divided by a unit of time. The unit we're going to use mostly in this section is going to be meters per second for speed. So let's look at a cheetah. If a cheetah can travel 50 meters in 2 seconds, then its speed is going to be 50 meters divided by 2 seconds, or 25 meters per second. Here's a table of some speeds in different units, and you can see a sprinter, like a world-class sprinter, can go 25 miles per hour. This is the one that people are always pretty amazed at. And look at a cheetah, 62 miles per hour. And then, as you know, a baseball, when it's hit, can travel about 100 miles per hour. That's its hit. There are some pitchers who can get it up and can pitch in 3 digits. And you can see the relative kilometers per hour for each of these and meters per second for each of these. 11 meters per second. So if you figure it's a 100-meter race, that means the sprinter can do it in under 10 seconds. Now, there's 2 types of speed. The first one we're going to talk about is instantaneous speed, and the important point here is that it's the speed at that instant. So let's start thinking about a car, and this car doesn't always move at the same speed. Sometimes it's stopping, sometimes it's slowing down, sometimes it's at 55 miles per hour, sometimes it's 35 miles per hour. So you can tell the speed of a car at any instance by looking at the car's speedometer. And we're going to see a picture of a speedometer. That's the speed of the car at any instant. That's how you can remember instantaneous speed. It's speed at any instant. So speed at any instant is called the instantaneous speed. Here's a picture of a speedometer, and you can see there's the dial. There's 2 sets of numbers, and this would be an American car. The white set of numbers, which I'm highlighting right here, are miles per hour, and this blue set of numbers here are kilometers per hour. And you see that in almost any car in North America, because the cars might go to Mexico or to Canada, where they talk in terms of kilometers per hour. So, in a car trip, a car will certainly not travel at the same speed at all during the trip. You're going to slow down, you're going to stop light, you're going to change speeds, you're going to accelerate. So a driver cares about the average speed, and this is the other type of speed we're talking about. So the average speed is the total distance covered divided by the time. Speed equals distance divided by time. So let's do a little math here. Let's say here's your average speed, total distance divided by the time interval. And let's say, for instance, you're traveling at a distance of 240 kilometers, and the trip takes you 4 hours. So what you would do is take the 240 kilometers divided by the time interval, 4 hours, and you end up with a result of 60 kilometers per hour. Notice the unit here, kilometers per hour. We have kilometers in the numerator, hours in the denominator, so we just rewrite it that way. We write kilometers sort of in the numerator, and then we have a slash which says per hour, which is in the denominator. So average speed can be very different than instantaneous speed. So you're talking, in both cases, you're still talking about the rates at distance traveled. And a rate, important thing about rates is that a rate is always going to be a rate. Let's see if we can get the pen working here. A rate is always going to be something divided by time. The rate of something happening per time. So, if we know the average speed, you can then find how far something has traveled. And that average speed is going to be your distance covered is going to equal your average speed times the time it takes to travel that. So let's look at an example. Let's say you go 80 kilometers per hour and you're on a 4-hour trip. What you would then do is multiply the 80 kilometers per hour times the 4 hours, and 80 times 4 is a total of 320 kilometers. So let's do a couple of math problems here. If a cheetah can maintain a constant speed of 25 meters per second, it will cover 25 meters every second. At this rate, how far it will travel in 10 seconds? How about in 1 minute? So, in 10 seconds, the cheetah will cover 250 meters, which is its speed, 25 meters per second, times 10 seconds. So it should cover 250 meters. And in 1 minute, which we also know is 60 seconds, we got to convert to seconds here. We would multiply 25 meters per second times 60 seconds to come up with 1,500 meters. By the way, 1,500 meters is roughly a mile. So it would take it about 1 minute to cover 1 mile at that speed. And I don't think that cheetahs can maintain that speed for over a mile. Hyenas can maintain pretty high speeds. They're closer to like 30 miles per hour, and they can hold that for miles, 30 miles per hour. So, the speedometer in every car also has something that records the distance traveled, and that's called the odometer. And here's our odometer right down here. So, if the odometer reads 0 at the beginning of a trip and 35 kilometers half an hour later, what's the average speed? Well, we know that it's traveled a distance of 35 kilometers. It was 0 at the beginning. At the end, it's 35 kilometers. So 35 kilometers minus that initial 0 kilometers gives us 35. And we're looking at half an hour. Now, there's a little trick here. Half an hour, this can be written as 0.5 at an hour. If you divide 0.5 of an hour into 35 kilometers, you get 70 kilometers per hour. That would be the average speed covered. This is from Ferris Bueller's Day Off, and in this scene, Cameron right here took out his dad's Ferrari, and he put a ton of well, he didn't put a ton of miles on it. The guys at the parking garage put a ton of miles on it. So what he did was he put the car up on jacks and tried to run the odometer backwards by running the car in reverse. And you can't do that. Odometers only run one way. You can't take miles off an odometer that way. So Cameron, if I don't know if what he does in the scene is he ends up getting angry at his father, and he pushes the car, and the car goes shooting out the back of this room, out of the garage, and ends up in the woods. And Cameron says, "What did I do?" And Ferris says, "You killed the car." And this was a spectacular car. So, how can you calculate speed? The way you can calculate speed is by dividing the distance covered by the time.